Okay, so now we're recording, okay? For people who aren't here right now. Okay, so now I'm going to review the homework document and talk a little bit about that. Okay. Sometimes if you have too many open, it won't get stuff around. Let me go into Canvas. Find it. Okay, you should be able to see Canvas again, right?
Right.
Okay, I'm going to go into the home page and go down to the homework list. And it's and I'm going to, oh Lord, come on. Bear with me, people. Homework list. Okay, there we go. Okay. Can you see a Word document now on my screen or not? No. Okay. Just a minute. Okay, it's right here. Okay, now you should be able to see it, right?
Yeah.
Okay, this is posted in Canvas. It's on the course resource section, and it's called Math Homework List. Okay, it's all the homework that I'm suggesting you do. Obviously, you don't have to do it, but if you don't do it, you're probably you're not going to get very proficient in that area. So I really suggest you do the homework. And there's quite a bit of homework. I'm not going to belittle that part of it. There's a lot of homework to do, but most of it is very quick. They're all simple little problems. But please go through and do all these. If you do all these and feel comfortable with them, you'll have a good feeling of mastering that area. Okay. What I'll do is you do that homework and this is due on next Monday. I will go over this homework. Anything you can't do or doesn't make sense, I'll go over. And that's the first thing we're going to do every time we do a lecture. We'll go over all the homework. All the answers are in the back of the book. Okay, so odd numbers, even numbers, it doesn't matter. They're all listed there. So you can get right to the answer and may leave out a couple steps, and that may be the confusing part for you. But excuse me, please look in the back of the book to make sure just to check your own, okay?
Murray,
Yes.
yesterday when I was at Newport College, I asked for the book and they said they didn't have it.
Well, you have to ask Steve Senny. He's got
Okay.
copies of it. He's
Okay.
the assistant dean. And
Okay.
his office, if you go in the main entrance, you make a right, and there's a table there. And then you make another right there and you go down that hall, and his office is the second or third one on the right. You just ask anybody in that college where Steve Senny's office is, they'll know.
Okay, I'll go back tomorrow and check.
Yeah, that would be good if you did, because seriously, we want everyone to get that book. He's got, umpty copies of that book, so that's not an issue, I know. Steve Sandy is the key. That's the guy you got to ask, okay?
Okay.
So please do, okay? And he even said if he wasn't going to be there, he was going to leave copies at the main desk when you come in. So, but please ask for him, okay?
Okay.
Okay, thank you. And that goes for everyone else. So please try to get a copy of this book, because obviously you can't do these problems if you don't have the book, right? So you got to get the book. Okay.
I did copy all of the pages that you had on Canvas.
Okay, well, very good. That was the lecture for Monday.
Okay.
Okay, and I'll do the same thing today. I'll put those copies. I'll put the pages that I'm going to go over on Canvas today also for you.
Okay.
But anyway, these are all the problems, and this is in Canvas too, of course. Okay, I just wanted to go over that. Okay, so now we can actually get to the lecture part, okay? So, back here, bear with me. Oops. I want to go to that 30. Okay, so the first thing I did, I sent out an email regarding regarding some homework to do for today, and it was in the last. No, wait a minute. It was right here. Come on, just a sec. Just a minute. Yeah. Okay, so for today, there was 4 pages there, and it was on chapter 1, and they're all pretty simple little problems. And I asked you to do the odd ones. So if you get when you get a chance, please do the odd problems. If you have problems with these, we can go over them on next Monday as well. Okay, and these pages will be posted in the Canvas if they're not already there right now. Okay, there's 4 of these pages. They look like this. The problems are pretty simple. I mean, they're meant to be. They're easy to count, to get the answer. So did anyone try these problems? I guess I know we're off to a sort of a weird start here, but if you tried the problems, are there any problems you had problems with? I'll go to them specifically. If not, we'll move on to the lecture. Lucero, did you have a problem?
I did them all except for 1 and 3.
Oh,
I
really?
didn't read the part where it said only odds.
Oh, okay.
Yeah.
Okay, yeah, just do the odd ones. You don't have to do them all, because it gives you a cross section of them. Okay.
Okay.
Okay. Well, good job for doing all of them except those. But
Yeah.
anyway, they're like number 1, a beverage container holds 12 servings. If the serving size is 8 ounces, how many ounces does a container hold in all? Okay. So this ends up just being a multiplication problem, right? We're going to take the 12 servings times 8. 8 times 12 is 96. Boom, D is your answer, right? All these are either multiplication or division or a combination of 2 or adding. They're just to be reflective of what was in chapter 1, okay? Okay, so I'm going to stop sharing that, and we're going to go on into chapter 2. Okay. Of course, now I lost my... Okay, here we go. Okay, so if I stop sharing, share. Okay, you should be able to see this page. Can you see the page called Decimals and Fractions, Lesson 1?
Mhm.
Okay, decimal basics. Okay, well, it's back to this this number line here, which we talked about last time, but now it's into the thousands, right? You've got the decimal point here to the left are the whole numbers, ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, etc. To the right of this decimal place are the decimals, the tenths, the hundreds, the thousands, the 10,000s. And some of these problems in this chapter are, round to the nearest thousand, round to the nearest hundreds, and so forth. So the first thing we're doing is, okay, so if you had a number like 3.62835 and you're asked to round to the nearest hundredth, you would look, and the 2 is in the hundredth column, right? Can everyone see that? Well, you look to the right of that, and the right is an 8. 8 is 5 or greater, so it means you add 1 to the 2. So the number becomes 3.63. Does that make sense? And at the end of this section, there will be some problems like that. See, 3.63, that's the answer because we rounded to the nearest hundredths, okay? Everything after the 3 is just considered zeros. We don't have to show them, okay? And this down here is just comparing and ordering, putting them in order. In this particular case, it's, compare the decimal parts of the number. Hold on. Okay, all we're doing is trying to find out what the largest number is. The key on this is putting that decimal point in the right place and comparing them that way. The 45.80 and 45.66. Well, the 0.8 is bigger than the 0.6, so therefore this is the larger number. Okay. Questions on that? I realize some of this is really basic to you and to some of you, but some of you it may not be. So I want to at least go over all of it a little bit. And please ask questions if it doesn't make sense. Okay. Okay. Next page. Right here. So it's upside down, of course. Okay, the second page on that, it's arranging the number. We're just arranging numbers in order, okay, from either largest to greatest or greatest to larger. And the key is to spot where that decimal point is and put things in order like that. Especially if you're adding or subtracting numbers, you want to put them in a vertical list, right, to add or subtract. Don't try to do it in a horizontal list, okay? Make it vertical. It's just a lot easier, okay? Some practice questions. Round 3.75 to the 10th place. How would you do that? What are we going to do on that one? Okay, I'm going to stop sharing and okay, and I'm going to share this. Oh, the whiteboard. Okay. Can you see my whiteboard now?
Yes.
Okay. So we had a number 3.75, and we said round this to the nearest 10th. You would look at the 7. That's what you want to round it to that, but you look to the right of that. 5 is a number that 5 or greater would mean you would add 1 to the 7. Okay. So what would your new number be rounded to the nearest 10th? Or anybody, what would it be?
3.8.
Exactly, 3.8. You don't have to put 0 after it. This would just be 3.8. That would be that number rounded to the nearest 10th. What if you had a number like this? 4.78. Okay, 4.7894. So if I said round it to the nearest thousandths place, how would you do that? First, you determine what is the thousandth place, right? My stylus here. Let's see if this thing work. The thousandths place is right here, right? That's the thousandths place. That rounded to the, and so we're going to round to that. We look to the right. 4 is less than 0 to 4 is obviously less than, I mean, it's not 5 or more. So you're not going to add 1 to this 9. So if that's the case, this thing rounded to the nearest thousands would look like what? What would it be?
4.789.
789. Right? It would just look like that. You drop that 4 off, right? But that's all you're doing on these. Okay, I'm going to stop sharing this. We'll go back. And back to this. Okay, so now we're back to this. Can you see my page now?
Yes.
Well, practice one, okay. So that's what we're doing in that first part there. Look at in each of the following pairs, which number is greater? What about number 10? 0.75 or, well, that's 1.85. That's pretty obvious, right? Because you got a 1 there, so it's an easy one. What about number 11? What's the largest number? Anybody?
1.0, the largest,
Yes,
1.029.
1.029, right? Because you looked at a third decimal and it's 7. Well, 9 is greater than 7, so you don't have to look any further. So you know that's the largest. Okay. Yeah, I mean, it's pretty basic, I think. I think some of these, they're a little hard to look at. So look at number 17. In the circuit board assembly, the weights of 3 parts are 0.572, 0.0785, and 0.6 grams. Which of the following list the weights in order from greatest to least? So these are the 3 weights. Put them in order from greatest to least. Which one? A, B, C, or D?
A.
No, greatest to least. You're going
C.
least to great. It'd be C, right? 0.6 to 0.572 and then 0.0785. Okay. Okay. Look at number 18. Which of the following correctly shows 1.3815 rounded to the nearest hundredths? Okay, the hundredth column would be the 8, right? I want to round to that, so
B. D.
it would be D, right? Because 1 is from 0 to 4, so you don't do anything with the 8, you just drop off the 1 and 5. Okay, good. Okay, stop sharing that. Go on to the next page. Okay, stop sharing. Share. Boom. Okay, next page, lesson 2. Make it a little larger here. Okay, decimal operations. It's just a little too large. Okay. Okay, when you're adding and subtracting decimals, like I was saying, you want to put them in a column, right? And what you want to do is you want to make sure that the decimal points line up, right? If they don't line up, you'll have more chance of getting a wrong answer. I'm going to put this on a board. 0.638. Okay, so I'm going to go and stop sharing. Share. Okay, so now we're back to my whiteboard, right? I'm clearing it. And you've got numbers of 0.37. See if I can do this by getting things in the right order. 13.500 and then 2.638. 2.638. Okay, so this is what we're trying to add. And I'm going to my little thing here. So we're adding these, right? So if this would like be a 0 up here, right? So I have to worry about that. So you're just adding that column first. I mean, my pen and everything's bad, but so it'd be 8. This one would be 7 and 3, which is 10, right?
Right.
You have to add 1 up here because it was 10. Okay, so it becomes 4, 5, What's 4 and 5?
9,
Would be 9,
Nine.
right? And then 9 and 6.
15.
Okay, so you put a 5 there, add 1 to that column. You've got 1, 3, and 2, and that's 6, right? And then
1.
there. So the answer is 16.508. Key is obviously just keep these lines up, keep the columns lined up. That's if you don't keep them lined up, you're going to get wrong answers for sure. So I'm going to stop sharing that and go back to sharing. I lost my page. I want to do this next one here. Okay. So, okay. Okay, so these are practice problems for adding and subtracting decimals, right? That's all we're doing here. Again, they're all lined up for you. When you do this, don't use a calculator, okay? Why don't you just get in the mode of just adding things up and subtracting things, and don't use a calculator, okay? Calculator is just your crutch in some cases. When you get to complicated numbers, then use a calculator, but this is to help you with your, with just the adding and subtracting skills. And there's certain problems on here that I would expect you to do for homework, okay? Just do them and keep track of all your homework. Well, the other thing I forgot to mention, can somebody unmute? So I'm getting feedback. I think it was, okay, I just muted one. I think that's better now. We will have a quiz on every Monday. We'll have a quiz over what we covered the previous Monday and Wednesday, okay? It'll be at the end of the time. I'll give you probably about 20 to 25 minutes to do the quiz. And usually it'll be like 10 little short little problems. It'll be a problem like this, number 5. Well, that might be on the quiz or something like that on the quiz. So you may have up to 10 of these kind of problems, depending on the complexity of the problem. But again, the reason for that is I want to get you into the habit of taking quizzes, taking tests, because you're going to have to continue to do that in your math courses, okay? And we'll just, as you take them, you'll get better at them. And you can take a screenshot of what you do. You can send it to me, and I'll grade it and send it back to you, okay? Okay, so these are the practice problems for this. Like, look at this one, number 21. See, they purposely put this thing in a row. Well, the first thing I would do in that is put it in vertical form, okay? And then do it. In fact, 1. I'm writing this down because we're going to do it. 0.996 and 1.5. So bear with me. Okay, so we're back to my whiteboard, right? See my whiteboard? And this particular one is 0.01. Below that is 2.2. Five, 2. Already come. In doing this, I want to make it more complicated. I have to put them in the right order, but this first number, 2.052, and then below that would be 0.9.8, and then below that would be 1.5. Okay, so that it looks like that. Back to my thing here. Okay, So we just, the key again, like I said, is to get the vertical call, get those decimal points lined up, okay? 1.5 is the same thing as 1.500, right? And all these, you could put zeros out here just to make sure you're got something in every column, right? Now this allows you to add things up. So what would be the third column? This is the thousands column, right? Be tens, hundreds, thousands. What's the addition for the third column? Anybody?
It's just 2.
Just 2, right? And then the second column, which is hundreds, you've got 1 and 5, 8. What's that?
14,
4.
Yep.
14,
Yep.
yeah.
And then carry the 1. And then in the tens column, what do you have?
15,
Yep. Carry the 1. And then in the 1 column, what do you have?
4.
4.
Exactly, right? So that would be the answer. The key is to put them all in the order. Keep track of your zeros, okay? Okay. Okay, so I'm gonna, I can find my, stop sharing that and go on to that page. Okay, so now we're back at the practice page and we just went over one like that. There's some of these problems are associated with tables, okay, with the data being in the table. This is one particular one. I haven't looked at it, but it says Claudia earns overtime pay when she works more than 40 hours in a week. How many hours of overtime pay did she work for the week of March 4th? And so this is the week of March 4th. So excuse me, so all you're doing here, this is the number of hours of overtime.
So 30 minutes.
Say again? Yeah, that would be, this would be 8 hours and 30 minutes if that's what you're asking. So what you would do is you would add all these up. Again, put them in the right order. I mean, it's hard to do this. It would be it's hard to do that without actually doing the math, right? Or maybe you can just go through there, but I think what they're asking you to do is write it out. Just, I have to put it here. And then 7.75, and we're going to add it. So we've got an 8.5, we've got a 9.25, an 8.75, a 10, and a 7.5. So you would be adding these up like that, right? So clear the board. Just going to put that there. Actually, I only need to go up to the third one. Point. And then the fourth one. And the fifth one. It would just be a matter of adding these things up at that point, right? Trying to do this without. So you go to the second column and forget, we don't need that thing there. We've got 5 plus 5 is 10, plus another 5 is 15, so it would be a 5, right? Put a 1 up there. What's the tens column going to be?
22.
So is it? I don't know,
Oh.
6, 8. Yeah, 8 and 14 is 20, isn't it?
20 or 22.
Yeah, 6, 8. 8, I'm just adding 2 tens. Oh, it is 22. You're right. I was thinking of the 6. Okay. So 22 and then add a 2, right? That would be 10, 19. Okay, 19, 27. So it'll be 27, 34, right? And carry the 1, and so this would be 2. Right? or excuse me, 34, this would be 4. So 4425, if we did it right. Now let me stop sharing that here. 4425, wasn't that what we said? So anyway, that's how you have to do these, okay? So we're going to stop sharing that. Go on to the next section. Because you do get into some other things here that okay, multiplication and division of decimals. When we're doing that, you're multiplying just like you would multiply, but you have to keep track of the decimal places. When I'm multiplying 2.6 by 0.45, when I get my answer, I have to make sure I go to the left, the number of decimal places that are in the both of these numbers. It'll be 2 here and 1 here, so I have to go over 1, 2, 3, so the answer becomes 1.175. And all these are like, all the multiplication ones are like that. Does that make sense? We want to just play around with a couple here. We'll just do a couple. We'll just make them up. Clear the board. So if we had a number like 3.45, and we were multiplying this by 1.1. Okay. And I'll get this thing over here like this. And so you'd say 1 times 5 is 5, so you'd put down a 5. You'd say 1 times 4 is 4. That's pretty easy. And then 1 times 3 is 3. In that second row, it would be a 0 in that the first place needs, because it's 1 column over. Then it's 1, so it's, this is really simple, right? 4, 3, adding all those up. So you got 5, 9, 7, 3. But the key is you've got 3 decimal places up here. 1, 2, 3. So you got to go back. 1, 2, 3. So it ends up being 3.795, right? That's how you do all these. Questions on that? So it depends on how many decimal places you have in your two numbers. You have to add them up and then go over to the left to account for those decimal places. Okay, that's what you do in multiplication. Same, well, division is a little different. So I'm going to go on to the next part, and that's division. You have to keep track of them, but it is different. So there'll be some problems like this, just like that, okay? On the division part, you have to keep track of the decimals also. Well, in this one, it takes care of itself. Down, I mean, 6 into 14.4. Maybe I can just look at it. 6 into 14 will go 2. Then 6 times 2 is 12. Subtract that from the 14. It's 2. Bring down the 4. 6 into 24 is 4. You got to make sure you put that decimal place right up there. 24 minus 24 is 0. Okay, that's how you keep track of the decimal place. Now on this one, you're dividing by 0.35 into 4.9. We're going to go ahead and do this guy. 0.35 into 4.9. So bear with me. I'm back here. Okay. Okay, I'm going to clear this. Okay, this one we have 0.35 divided into 4.9. So what we can't divide, when we're going to manually divide, we can't divide the division or the any number less than 1. So we have to make it a whole number. So to do that, I'm going to move the decimal over 2 places. So this, I'm going to move it over here. when I do it, if I move this over here to make it 3, or actually one place to make it 3.5, I have to move this over to make it 49. So really what we're doing is, well, actually I want to get rid of my decimal period. So I want to move it 2 places over. So it's going to be 35 divided into 490. Okay. Now I can go ahead and divide. So now we have 35 divided into 490. And I purposely putting things out a little bit like that. So, so now it looks like this. Okay. You started out with 0.35 divided into 4.9. Now, but the real problem is when you do it manually, it's going to be 35 into 490. Everyone understand that? You see what I'm doing? I'm just moving the decimal place over. So I get a whole number in my divisor, right? This is the divisor. The divisor into the dividend gives you the quotient. Remember we talked about that? Divisor, dividend, quotient. Quotient is your answer. So now you say, well, how many times does 35 go into 49? It goes once, right? Sorry for the sloppiness, but it's just what I'm working with here. 9 minus 5 is 4. So it's 14. Now you have to bring down that 0, right? And 35 into 140. How many times does 35 go into 140? What do you think? Anybody? It goes exactly 4 times. They're making it easy for you. So it's 4 times. Okay. So the answer to this, 0.35 divided into 4.9. So you could rewrite it like this. 4.90 divided by 0.35 is equal to 14. Okay. This is the dividend, this is the divisor, this is the quotient, right? Make sure you write this down so you know it. Dividend divided by divisor is equal to quotient. Okay. Questions on that? This is the basics of the whole thing for all your dividing, okay? Put it into a whole number, then go ahead and divide it. Questions on that? Okay, so I'm going to assume that you can do that. If you can't, practice it, and if it still doesn't make sense to you, you can email me, and I'll respond as soon as I see these emails. Okay, I want to make sure you guys understand how to do this stuff. Okay. Okay, that's what we've done in that page. I'll stop sharing that. I'm going to go on to the next page. Okay, here's the next page. Okay, so these are the practice problems for lesson 2, right? Remember, when you multiply, you have to keep track of those decimal places. When you do this, 1.5 times 5.3, whatever number you get, you're going to have to go back to the left 2 places to account for the 0.3 and the 0.5, right? Okay. On this one, you would just divide this. Let's do this one, okay? It is a little different. 6 into 3.12. So I'm going to stop sharing, go to my whiteboard, boom, get rid of this, and so that was 6 into 3. or 5 or what, it doesn't matter. Right? Oops. 3.5. Like that. So now, okay. Oh, I didn't even, it doesn't, yeah, it's okay. Okay, so this one's like this. So the key on these division ones is make sure you know where that decimal place is, right? So 6, you can't go 6 into 3. So we know that that's a 0. So you put a 0 right there, and then make sure you see that decimal place. Now you say 6 into 35. How many times does 6 go into 35? Well, I'll show you how I got that. Because the 6 times 0 is 0. 3 take away 0 is 3. Now I bring down to 5, right? So 6 into 30, what's 6 into 35? How many times is it?
5 times.
How many?
5.
5, right? Because it can't go 6, because that would be 36. So it is 5, right? Oh, that's a terrible 5, but anyway. And so you put a 30 down here, subtract it from that, down to 5, now you bring down the 2, right? How many times does 6 go into 52? Anybody?
9?
How many?
Would it be 9?
No, 9 times 6 would be 54. So that's just a little bit too much,
8.
right?
8
So
times.
There we
it'd have
go.
to be 8, right? So 8 times 6 is 48. That's the other thing on doing these, and this would be 4 left over. You can put another 0 up there to bring down that 0, right? What was I getting at? So you really have to know your math, your multiplication tables to do these efficiently, or you're going to get all messed up. So it's important to refresh yourself on those multiplication tables. Either that or have a copy of that multiplication table right beside you when you're doing these to help you. Because if you don't, it's really hard to do it. So how many times is 6 going to 42?
7.
7, right? And it goes exactly 7, right? So there's nothing left over. So this is the answer. 0.587, right? So you'd be like this, 3.52 divided by 6 is equal to 0.587, like that, right? That's how you would write that. And we did the manual division so that we could do it. The key is we kept track of that decimal place, right? That's really important. Okay. Okay, so I'll stop sharing that. And we'll go back here. Share. Okay, can you see it's practice 2.2 page again?
Yes.
Okay. Of course, so you've got multiplication, you've got division. Just remember when look at number 17. What's the first thing you have to do with number 17 to make that work?
Line it up.
No, not round it up.
Line it up like vertical.
Line it up, okay. Yeah, line it up, exactly. That's exactly what you'd have to do. And let's look at, I want a division one that's, no, there's no, let's look at number 16. What's the first thing you have to do in that one?
Line it up.
Decimals.
To do what?
Line it up.
Well, not line it up, no, because we're dividing,
Oh, yeah, but yeah.
right? So we're dividing, so since we're dividing by a decimal, 0.5, what do we have to do?
Round
Get
it
rid
up.
of the decimal.
Not round it up, but yeah, you're gonna have to,
Oh, the decimal.
yeah, gonna have to make it a whole number, right? I'm gonna do that one on the board because it's important to understand this concept here. 1.35, so, okay. I'm gonna show you. Okay, let's get rid of that. So what we want to do, the problem is 1.32 divided by 0.5, right? Something like that. Okay, we want to manually divide it. So we have to take this divisor, that's the one on the bottom. So it's 1.32 divided by 0.5. That's what it looks like. We have to take this divisor and make it a whole number, right? And to do that, we're gonna move it over one place to the right. If we move this over one place to the right, we have to move the dividend over one place to the right, the top number. So when I multiply this by 10 and this by 10, this becomes 13.2 divided by 5. Does that make sense? This is really the key. When you're dividing by any decimal, you have to convert it into a whole number. Okay, so now once we do that, then we can go ahead and put 5 into 13.2 and we're going to put our divider sign in like that, right? So now it's 5 into 13.2. Now we can go ahead and divide. What's 5 go into 1? It doesn't. 5 go into 13 how many times?
2.
2, right? And so it's 10. 3 left over, bring down the 2. Make sure you put your decimal place up there. 5 into 32 goes how many times?
6.
6 times, right? 2 left over. This thing just goes out as far as you want it to, as far as zeros. Bring down the next 0. 5
4.
and 4, right? So it ends right here. So this becomes your answer, right? So what we had to do, we had to convert that 0.5 into a whole number. Okay? That's the takeaway on this. That's how you, anything that you're with a divisor less than 1, you have to convert it into a whole number. Okay? And then go ahead and do your division. And in doing your manual division, make sure you understand the multiplication tables. If you have to have one beside you, that's fine. But one way or another, you have to, you have to understand them for sure. Okay, questions on that? That's really that's the essence of this chapter, really. This part of it, in my mind. Okay. So let's go back. Share this. Yeah. I'm gonna go on. What time is it here? Yeah, I'm gonna keep on going here. I want to complete the lecture, so we're gonna stop sharing that. Okay, stop sharing that. Share. Boom. Okay, lesson 3. This is this is important. Let me make it bigger. Fraction basics, okay. You're just using blocks or tape diagrams or whatever to represent whole numbers and fractions. So if you see something like this, 3/4 of this rectangle is shaded in, right? So the fraction would be 3/4. 4 meaning the whole, all of them, and 3 meaning what's shaded in. On this particular one, this is 6. It's really 6/6, so it's 1, right? This one down here is 2 circles. This would represent 1. This would be 1 and a, so this would be a half, so it would be 1 1/2. Or they say 3/2, which is the same thing as 1 1/2, right? Understand the concept of mixed number. A mixed number is a whole number and a fraction, right? This would be 1 1/2. That would be a mixed number. An improper fraction is where the numerator is greater than the denominator. The top number is greater than the bottom number. And so the improper fraction of 1 1/2, you take the 2 times the 1 plus the 1, so it would be 3/2. I'll do some on the whiteboard to explain or to help clarify this too. Change 16 into divided by 5 is a mixed number. So I'm going to stop and I'm going to go to the whiteboard. Okay. Now, some of this stuff may be real easy to you, and others you haven't done it in years. So please bear with me. Okay, it's important. So if we had a number like 16 and that was divided by 3, this would be in the form of an improper fraction because the numerator is larger than the denominator. How would you convert this to a mixed number? What you have to do is you have to take that 3 and divide it into 16. Okay? So again, you got to know your multiplication table. So it's 3 into 16. 3 won't go into 1, of course, but it'll go into 16. It'll go 5 times, right? Right? So 5 on the top. Oh, shoot. Use my mouse here. And 3 times is 15. That's a 5. Terrible looking 5. There's 1 left over. So this would be a 5 with a remainder of 1. This 5 and a remainder of 1 is the same thing as 5 and 1/3, right? So this is equal to this, right? Does that make sense? That's what you have to do in all these when you're converting improper fractions to a mixed number. Let's do another one. What if we had like 19 fourths? 19 over 4, that's an improper fraction. The mixed number version of that, you would say 4 into 19, and we do the math. We do the division, right? So 4 into 1 doesn't go. 4 into 19 goes how many times?
4.
It goes 4 times, right? And 4 times 4 is 16. 3 left over. So that's a remainder of 3. So we rewrite this as 4 and 3/4, right?
Good girl.
So
Local body?
so the 19, so the 19 divided by 4 is the same thing as 4 and 3/4. Does everyone understand this? Questions? This is in your homework. It's really important to understand this part, right? Improper fraction, mixed number. Now we can go the other way. Let's say we know what the mixed number is. Say the mixed number is 3 1/2. And I asked you, what's the improper fraction? Put this in an improper fraction, you would take the denominator times the whole number. So it would be 3 times 2, and you would add it to the fraction part of it. So it'd be like this. So please write this down. Make sure you understand this. Divided by 2. And we're not done yet. So now 3 times 2 is 6, plus 1 is 7. So it becomes 7 over 2. Okay. Does that make sense? The 3 1/2 is the same thing as 7 over 2. I converted a mixed number to an improper fraction. Let me do another one. What if we had 3 1/4? I want to convert that to an improper fraction. I'm going to say 4 times 3, or 3 times 4, plus the 1, right? Plus the 1. Put brackets around this whole thing because this becomes the numerator, right? Divided by the 4. So 3 times 4 is 12, plus 1 is 13. So it becomes 13 over 4. Okay? Make sure you write these down, okay? So you can understand that. So how to convert 3 1/2, how to convert 3 1/4, both to improper fractions, okay? Questions on that part? It's really important to understand that, okay? Okay, I'm going to stop sharing that. Go back. Okay. And that's what we're doing in all these. That's what we did. Like this one, 7 2/3. We said 3 times 7 is 21. 21 plus 2 is 23. So it becomes 23 over 3. Okay, we converted the mixed number to an improper fraction. Okay, stop sharing that. And we'll go on to the next page. I realize there's a lot here. I mean, there really is. I'm not minimizing it, but you have to get it somehow. And I think it's just practice, and that's why I give you all the homework to do, okay? It just reinforces what we're doing. Here's the practice homework for this section. Again, it's writing proper fractions for the shaded area. This would be, what would 1 be? You put this in terms of a fraction, shaded over total, what would it be? Anybody?
3/5.
Yeah, 3/5, exactly. Okay, so let's look at number 5. What would number 5 be as far as a mixed number goes? You got 3 whole ones, right?
Right.
Mhm.
So the mixed number would be 3,
3 and
what?
1, or
3 and
1/6.
3 and 1/2, right? 1/2, right? Look at
Yep.
this one here, number 6. You got 3 whole ones, and you got 3/4 of one, right?
Mm-hmm.
So it would be 3 and 3/4, right?
Right.
Okay. All these here, we're converting these mixed numbers or these improper fractions to mixed numbers. We're dividing the denominator into the numerator, right? Manually dividing all these, just like I did on the board, okay, for these top rows. This, yeah, and we're just going we're going mixed numbers. So this one, you'd be 5 times 9 plus 2 over 9. All these would be converted, again, just like I showed you on my whiteboard, right? That's what that whole section is about. So just look at it and do some of these problems, and that should help reinforce it. If you have any questions on that, please email me and say, this doesn't make any sense at all, and I'll be glad to work with you on it, okay? Also, part of my virtual office hours are from 10:30 to noon, Monday and Wednesday. You can pop in anytime. Either call me, email me, or I'll leave my Zoom link open. You can just, boom, get in that and say, I have a problem on this, and I'll be glad to work with you on it, okay? Okay, so I'm going to stop sharing that, and we have one more section to do, and then we'll take a break, okay? But I'd like to get this done before I take a break. Okay, so this is fraction operations. Okay, this is adding, subtracting, adding, subtracting fractions. So adding fractions, you have to have a common denominator, right? That lower number has to be the same. And that's what they're showing here. 3/10 plus 5/10. I'll make it a little larger here. Okay. This would be 8/10. And then you want to reduce to the lowest terms. What's the common denominator for an 8 and a 10? Well, they're both even numbers, so it's always 2. You can always start out with 2. 8 divided by 2 is 4. 10 divided by 2 is 5, right? Same thing in subtracting. You have to have a common denominator. You can't subtract it. Okay. And when you're adding fractions, it has to be a common denominator. So 5/6 and 1/4. How do they do this? So they look at the common multiples of both numbers, and they find the lowest common denominator. In this particular case, it ends up being 12. I'll go over this on a board here for you just a minute. I have to write it down. 5, 6, 1/4. So let me stop sharing. Go here, go here, here. Okay, so I can get rid of this, clear. So now we've got 5, 6. Was it 5, 6 minus 1/4? Something like that. So what we have to look at these denominators, we have to have a common denominator. So you have to find what's the common multiplier of both of these, the lowest common multiplier. The way you do it, you would put 6. What are the multipliers of 6? 1, 2, 3, 6, 12, 18, you know, keep on going, 24. Those are all the multipliers of 6. You do the same thing with the 4. 4. 1, 2, 4, 8,
12,
12,
15,
right? 16,
20.
20. So now you look at what's the lowest common one. What is the lowest common one for both of these?
2?
No. Excuse me, the highest common one. Sorry. It'd be 12, right?
Okay.
So we'd have to convert both of these to 12ths. So how do you do that? So you take the 5 over 6. Oops. I have to put divided by 6. You want to convert this 6 to a 12. So it means you have to multiply by 2. So you have to do same thing on the top as on the bottom, right? So it's going to be 5 times 2 divided by 6 times 2, right? And what's 5 times 2?
10.
10. So it's 10 12ths, right?
Oh,
So now we converted the 5 6 into 12, so we do the same thing with the 4s.
gotcha.
1 4 is equal. So to get 12, what do we have to multiply 4 by to get 12?
3.
3, right? So you do the same thing. You have to multiply the top and the bottom by 3, right? So this becomes 3 over 12, right? Now we've got both a common denominator. Now we can go ahead and say 10 over 12 minus 3 over 12. That's the same thing as 10 minus 3 over 12, right?
7.
Put all this down so it makes, you know, after you look at it enough times, it'll make sense to you. So 10 over 3 divided by 12. So now we've got that. So now what's 10 take away 3?
7.
7, right? So it ends up being 7 12. 5 6 minus 1/4 is 7 12. Okay. And we had to go through all these little exercises to do it, right? You had to get a common denominator. You had to figure out what that would be. You could go higher. You could be 20. You could use 24 as the common denominator if you wanted. I just did, you know, I could have gone out, but we want the lowest common denominator that each would end up being in. So that's how we get 12. Okay, questions on that? That's the essence of that part of it. That's what you got. That's what you have to do. I don't think there's anything else on that page. Let me look here. That's the same idea. That's what that's all about. Stop sharing that. Going to the next. Okay, we're almost there. Cool.
There you go. There you go.
Okay, one more page. Okay, so these are practice problems on just what we did. Reduce, okay, simplify. So here we're adding when you see two fractions together, you have to have a common denominator, right? I can't add 1/4 to 2/3 directly. I have to convert it. In this particular case, you could just multiply the denominators together and get a common denominator. In other words, 4 times 3 is 12, so I can convert both of these to 12ths and do it, right? You can always do that in these cases. You can always take those bottom numbers, multiply them together, and that becomes your new denominator for improper fractions. When you get to a mixed number, then you've got to do your conversion first, right? Well, there's two ways of doing this. One, you could convert both to improper fractions, or you could add the whole numbers and then just convert these to an improper fraction. So there's two different ways of doing that. It's sort of your preference. Either one's it's gonna give you the right answer. Do you understand when I say that, what that means? 2 1/5, and we're adding that to 1 2/3. Okay, so here, I'm gonna stop. And this will probably be the takeaway for that thing here. Okay. Okay, this is gonna be the last problem we're gonna do, okay? Come on. Okay, so it is 2 1/5 plus 1 2/3, right? That's the problem. We have to have a common denominator to add these fractions. So in this particular case, I'm going to say the 2 and the 1, I'm going to keep it separate and just look at the 1/5 and 2/3, and then add the 3 to it. Okay? It's probably the simplest way to do it. Do you understand what I mean when I say that?
Yeah.
So what I'm saying, I'm going to add that, and then I'm also going to add the 2 plus 1, right? So it becomes 2 plus 1. That's equal to something. This is equal to something. I know this is 3. I just have to figure out the 1/5 and 2/3. I can always take those denominators and multiply them together and get 15 and use that as my denominator. And that's what I'm going to do. I'm going to take the 1/5 times, times 1 times 3, because I know that I'm going to multiply it by the 3 by 5 times 3. So it becomes 3 over 15. Okay, that's the first number. All I'm doing, I'm converting to a 15 on the denominator. Do the same thing with the 2/3. Okay. This is wrong up here. Sorry. Let me get something right for you. Sorry. 1/5 is equal to 1/5 times 5 divided by, oops, 3 divided by 5 times 3 over 15. That's what that 1/5 converted to. That's what it should look like. Okay. Now the bottom one. Here. Okay, the bottom one is 2/3 is equal to 2 times 5 divided by 3 times 5. So I get 10 over 15. Okay, so now I've got 3/15 and 10/15. I can add those together. So the big picture, it looks like this. It looks like the 2 and the 1, so it looks like 3 plus 3/15 plus 10/15, which is equal to 3 plus 10 plus, plus 3 divided by 15. Which is equal to 3 and 13/15. Okay, so this is how you solve this problem. 2 1/5 plus 1 2/3 ends up being equal to 3 and 13/15. Does that make sense?
Getting there.
Okay, okay. Okay. Well, that's what you have to do. So at this point, I think we need to take a well-deserved 10-minute break and then come back, and we'll just end up working more problems on these 4 little sections here. And if you can pick out particular problems you want me to work on, I'll be glad to do that. But that's what we'll do, okay? So I'm going to end the lecture here, and we'll take a 10-minute break, and I'll see you at 9:33, okay?
All right. Thank you.
Thank you. Okay. So let me figure out how to do this.
Let's go potty, Romy. Come on,
Okay.
potty. Romy, you
Uh,
need to go potty. You need to go potty.
Stop